So hello everyone, today we'll be learning arithmetic progressions. Consider the following list of numbers 1, 2, 3, 4 and so on. 100, 70, 40, 10 so on, minus 3, minus 2, minus 1, 0 and so on. 3, 3, 3, 3. And each of the numbers in the list is called a term. So each number is called a term. Then given a term, can you write the next term in each of the lists above? If so, how will you write it? Perhaps by following the pattern or rule. Let us observe and write the rule. So they're asking us how are we able to write the next term in this sequence or in this pattern. We'll obviously observe the previous pattern that has been coming. So this is nothing but the list of all natural numbers. Since this is going from 1 to 2, then 3, then 4. So logically it follows that the next number would be 5, then 6, then 7, so on. In such a case, there's a gap of minus 30 in each of the numbers. So it would go on increasing like minus 20, minus 50, minus 80, like this. Similarly, in this case, it would go on minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, and like this. So we have deduced what the next terms would be by looking at the basic pattern of this list. We have looked at the previous terms and we have concluded a pattern from this. We found a pattern and now we'll follow it according to the pattern. Let us observe and write the rule. So in first, each term is 1 more than the term preceding it. In the second, each term is 30 less than the term preceding it. In third, each term is obtained by adding 1 to the term preceding it. Right? So this is how it goes. In all the list above, we see that successive terms are obtained by adding a fixed number to the preceding term. Such a list of numbers is said to form an arithmetic progression. So we have seen that what we have seen is that we add 1 to 1, then we get 2. Now we add 1 to 2, then we get 3. Now we add 1 to 3, then we get 4. So we're adding the same number, the exact same number in each of the term to form the next term, right? In the same case, if it's about subtracting, then we'd subtract the exact same number from each of the terms to get the successive term. It's not like we subtract 30 from 100 and then we start subtracting 40 from 70, and in the next term we subtract 50 from 40. In each of the case, if we are subtracting 30 from 100, then we would subtract 30 from 70 also, from 40 also, from 10 also. So in each of the cases, a single number is either added or subtracted to form the successive numbers, to find out the successive numbers, right? So this is why it is called forming an arithmetic progression in which a fixed number is added or subtracted from the previous term, from the preceding term, to form the successive term. So an arithmetic progression is a list of numbers. It is a list of numbers in which each term is obtained, in which each next or each successive term is obtained by adding a fixed number to the previous or preceding term, by adding a very particular and particularly fixed number to its preceding term or its previous term. Now when we say that we have subtracted 30, we can also say that we have added minus 30 into it. Okay, right? So you say that we have subtracted 30 from it. So let's say that we have to say that we are subtracting 30 from 100. So we will write it like this: we are subtracting 30 from 100. But we can also say that we are adding 30. We are not 30, we are adding minus 30 into 100. Now this is equal to 100 minus 30. So both of them are same. You can either say that we are adding minus 30 into it, or you can say that we are subtracting 30 from it, right? So both are same. So we can even write subtraction in terms of addition too. That's why there's no need to particularly write by subtracting or adding a fixed number. You can simply write by adding a fixed number to the preceding term, except for the first term. Now why is first term excluded? Because if we add that number from the first term, that we cannot conclude the pattern. Suppose that we have to subtract 40 from 100, and in the next term we have to subtract 30, and in the other term we have to subtract 40, and in the other term we have to subtract 30. So it goes on like this: 40 30 40 30 40 30. So if we subtract it from the first term also, then we won't be able to know what the pattern is, right? What the pattern follows. That's why the first term is an exception. This fixed number is called the common difference. Now this is called the common difference between all the terms, or the common difference of the AP. Remember that it can be positive, negative, or even zero, right? It can even be zero. Like in the case of here, in the case of fourth equation here, it is zero. The common difference of this AP is 0, 3, 3, 3, because it goes on like this, 3, 3, 3. Nothing is being added or being subtracted. Now moving on, let us denote the first term of an AP by A1, right? We denote the first term of the AP by A1, second term by A2, and till the nth term. Nth term means as much terms as are required or as are asked. By AN. The nth term means whichever term you want to name it. That can be or however far you want to go in these terms, like you want to write the first 15 terms, first 20 terms, or 25 terms, whatever that number is, it would be replaced by n here, the small n here, as you can see, this n here. This n would be replaced by the number of terms that you want to write down, right? So it basically means the xth term, we use here the nth term, however, just for saying. And the common difference we can denote by D can be used to denote the common difference. So the AP goes on like this: A1, A2, A3. That is A1 and A2, A3 successively represent the terms. The numbers below them, below the A, represents the number of the term. So A1 is the first term, A2 is the second term, A3 is the third term, A4 would be the fourth term, A5 with the fifth term, and so on till AN. AN means however far or whichever term, till whichever term you want to continue this pattern, this line, this series, till whichever number you want to continue it, right? So here it is, A2 minus A1 is equal to A3 minus A2. So since we've already discussed that the same number is added or subtracted from each of the terms, so A2, that is the second term minus first term, the difference between the second term and the first term would equal the difference between the third term and the second term, and it would also equal the difference between the fifth term and the fourth term, or the seventh term and the sixth term, or the ninth term and the eighth term, right? Because all of them have the same successive gaps. Like if we write it like this, okay, so this is a point here, this is a point here, this is a point here. Now it goes on successively like this. I'll say roughly the difference between both the points is the same. In each case it's the same point. So if you want to find out the distance between these two points, so let us say this point is 50 meters, this point is at 50 meters distance, this point is at 0 meter distance. So you would subtract 0 from 50, then you get the distance between both of them, that is 50 meters. Now this would be obviously 100, this would be 150, 200, 250, 300, right? This is how it will go on. Now since we know that the difference between each of them would be same, and let us say this is the A1 term, that is the first term, A2 term, A3 term, A4 term, A5 term, A6th term, A7th term, and A8th term, right? So A2 minus A1, just like we read here, where was it? Yes. Just like we read here, it's A2 minus A1 is equal to A3 minus A2. That is the second term minus first term is equal to the third term minus second term, right? So here we go, the second term, this minus the first term, that is 50 minus 0. 50 minus 0 is equal to the third term minus the second term. The third term minus the second term, that is 100 minus 50 is equal to 100 minus 50. And we can clearly say that both of them will end up with 50. This will also come as 50, this will also come as 50, right? This is the difference between all the successive terms and its preceding term would be the same in all the cases, right? So whatever the difference is between the first and second term, the same difference would be with the second and third term, the third and fourth term, the fifth and sixth term, the sixth and seventh term, and so on. Now some more examples of APs are 147, 148, 149 till 157, right? They are moving in successive terms like plus 1. Everything is just being added. 1 is being added to every term here. 147 plus 1, 148, 148 plus 1, 149, and so on till 157. Right, so these are some examples of arithmetic progressions or terms. And the basic form of a term is, we can just, this can be known as the basic form of an arithmetic progression. Like how it would move on, it would go, first would be a, obviously nothing would be added with the first term, right? Because we have to start from somewhere, so we can't directly add anything in it, because we have to start from somewhere at least. Then in the next term we add something so that it differentiates from the first term, or you can even add 0 here, so it won't differentiate from the first term in any matter, but in a written sense you would write here that how I added 0 into it. So in the second term, if you want to write the second term, you had to multiply the difference by 2, right? That multiply the difference by 2, or just add the same difference but in a plus d, right? If you want to add into the first term, then you had to add 2 times the difference, 2 times the common difference between these terms, right? I think it's very understandable why we have to do this. So let's move on. So now there are finite APs and infinite APs. Finite APs go up to some particular point like this here. This here started from 147, ended at 157. This is a finite AP, right? This also started from here, ended here. This also started from 950, ended at 50, and so on. These are all finite terms. But suppose we just let us see an example of infinite terms. Now all of these are infinite terms. Every one of these are infinite terms, because in the end there are dots left. So this means that the series or the arithmetic progression continues, and they have not mentioned how far it will continue, so we will just have to assume that it continues indefinitely, infinitely, right? So these are infinite arithmetic progression, and these are finite arithmetic progressions. Okay, enough to know the first one. Is it enough to know? Now we will do some operations on arithmetic progression. So we all know a is used to denote the first term of the arithmetic progression, d is used to denote the common difference between the arithmetic progression, and an is used to denote the required term of the required number term of the arithmetic progression. Like we want to find the 10th term of the arithmetic progression, then we would write a subscore n is equal to a by a subscore 10, right? We will write it like this. So if you know what a and d are, you can list the AP, right? But if we know what a and d is, like what is the first term and what is the common difference that is being added to each term, we can easily write an arithmetic progression. And why we can write an arithmetic progression? Because they've told us that the first term is suppose a, and each time number or the common difference is nothing but the number that gets added to the term each time, every single time. So the common difference d is equal to like 5, okay, and the first term is given as 1. Then we will simply add 5 to the first term, it would form 6, that is our second term. Now we will add 5 to the second term, this would give us 11th, that is our third term. Now we will add 5 to the third term, that would give us 16, that is our fourth term, and so on we will go. However far we want to take this series sequences, it's up to your choice, or as asked in the question. So if you know what a and d are, you can list the AP. What about the other way around? That is, if you are given a list of numbers, can you say that it is an AP and then find a and d? So suppose we are given the a and d, we are given the first term and the common difference, and we can create an AP very easily. But if we are already given an AP, then can we find its first term and the common difference between them? Obviously it's very easy, you can easily do it. So since a is the first term, it can easily return. We know that in an AP, every succeeding term is obtained by adding d to the preceding term. So d found by subtracting any term from its succeeding term. That is the term which immediately follows, it should form an AP. For example, for the list of numbers, now you can easily find the common difference between them. How? Just subtract the first term from the second term, and then the third term from the second term, then the second term from the third term, and the third term from the fourth term, to just check your answer, evaluate if you are right. You know why? Because if you have to find the difference between two things, then you would subtract the smaller thing from the bigger thing, and you would know how much of gap they have in between. Like if you want to know the gap between 6 and 9, then you would simply subtract 6 from 9. If you want to know the gap between 9 and 12, you would simply subtract 9 from 12, and you will know how much gap is between them, and that is your common difference. That is the common difference, that is d. So you can easily find d. And what is a? A is the first term, which is 6 here. So a would be 6, d would be 3. But yeah, that's right, d would be 3. Like 6 plus 3 9, 9 plus 3 12, 12 plus 3 15. That's what d is, and it would be same in each case. Here the difference of any two consecutive terms in each case is 3. So the given list is an AP whose first term a is 6 and common difference d is 3. So for the list of number 6 3, so it would continue for this particular list here, 6 3 0 minus 3. You can easily see that the first term here, because it has started from this point, now we cannot see the last term because this is an infinite AP. It has been ended with dots because this continues infinitely. But you can easily observe that the first term here is 6 and then the second term is 3. So to check the difference between the simple shortcut formula is actually there's absolutely no need for any shortcut to find the difference. But if you still can't understand and you want to apply any shortcut, the shortcut would be